right, so we're going to be working on two separate worksheets today. So I would encourage you to pause when I say pause so that you can make sure that you're getting everything down. So we're going to start up here. The result of squaring a number is called a perfect square. For example, 1 squared is 1, 2 squared is 4, and 3 squared is 9, and therefore 1, 4, and 9 are examples of perfect square numbers. Why are they called perfect squares? When drawn geometrically, perfect squares create a perfect square. Draw the next three figures below. So we have 1 squared, 2 squared, 3 squared. So our next one is going to be 4 squared. 2, 3, 4. And then we're going to go over 1, 2, 3, 4. And then when we count, this is 4, 8, 12, 16. 16 goes in the middle. 4 squared. So pause it right here and do 5 squared and 6 squared. Okay. All right, and so now we are going to find the perfect squares. So 1 squared is 1, and 2 squared is 4, and 3 squared is 9. Pause it right here and finish filling in this table. All right, and so then a non-perfect square is a whole number that is not a perfect square. And so you need to circle your even numbers. Okay. So if we're looking at this for number 2, determine if the number is a perfect square. Write yes. If yes, write the number as a whole number squared. So 50 is not a perfect square. 16 is a perfect square, and its whole number squared is 4 squared. 175 is not a perfect square. 160 is not a perfect square. And so now it says fill in each set of boxes with consecutive numbers that make the statement true. So 14 is in between what two squares? So 14 is in between 3 squared and 4 squared, because 3 squared is 9 and 4 squared is 16. So 14 is between 9 and 16. Number 12, 78, is between 8 squared and 9 squared. Now number 14, things are going to get tricky, because it has to be a perfect square, so the answer has to be in the table that you filled out on the front, and it has to be divisible by 4. So 12 is not a perfect square. 36 is a perfect square, and it's also divisible by 4. 48 is not a perfect square. 100 is a perfect square and divisible by 4. 128 is not a perfect square. 144 is, and it's divisible by 4. 200 is not a perfect square. 256 is, and divisible by 4. And then 264 is not. Number 16, we're looking for a non-perfect square, and it has to be odd. So 5 is a non-perfect square. 25 is not. 64 cannot fit this rule because it's even. 105 is a perfect square. 141 is a perfect square. But it's not a perfect square, and it's also odd, sorry. 169 is a perfect square, so it can't be shaded. 256 is even, so it doesn't apply. 289 is a perfect square, so it should not be shaded. And 361 is also a perfect square. Okay? You don't need to worry about with a partner because we're not doing that. So you need to complete the odd numbers for a grade. Pause it right here and do that. And then we are going to circle the even numbers. All right. So in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, 2 times 2 times 2 is 2 to the third. Parts of an exponential expression, the x is the base and the n is the exponent. And it's read as x to the n power. And so now we're going to rewrite these, and then you're going to solve them if necessary. So 23 times 23 is 23 squared, and that value is 529. 11 times 11 times 11 is 11 cubed, and when you solve it, it's 1331. Number 6 is 2 to the 7th power, which is 128. Number 8, we're going to write fractions using exponents in a parentheses. So it's going to be open parentheses 1 over 3, and we have 4 1/3. And then for fractions, we're going to multiply straight across. So 1 times 1 times 1 times 1 is 1. And then 3 times 3 times 3 times 3 is 81. And then number 10, we have a to the 7th power. Nothing should be here because this is a letter. We cannot solve letters. For number 12, it's going to be m squared times n to n cubed. Nothing should be here again because it's letters. We can't solve it. And number 14 is c to the 4th power times d to the 5th power. Again, nothing should be here because we can't solve it. So we turn it over. And the square of an integer is called a perfect square. You need to make sure that you fill in these blanks. So you can pause it here to do that, or we can keep going. So the opposite of squaring a number is finding the square root. And so now you will need a calculator. And so we're going to find the square root of the even numbers. And so we're going to do the square root of 4 is equal to 2. The square root of 289 is 17. The square root of 169 is 13. For numbers 22 to 27, we're going to be rounding to the nearest 10. So for 22, the square root of 90. And we have 9.486. And we're going to look at these first two. We're going to round to the nearest 10. So this 8 is going to cause us to round up. So this is going to be 9.5. And then we have the square root of 12. This 6 is going to cause us to round up. So it's going to be 3.5. And then we have the square root of 148. And that 6 is going to cause us to round up, so it's going to be 12.2. So number 28, the area of a square is 64 square inches. What is the length of one side? So we're going to find the square root of 64, which is equal to 8. Then number 30 is a multi-step problem. Greg and Jax each have square-shaped rooms. The area of Greg's room is 144 square feet, and the area of Jax's room is 196 square feet. How much longer is each side of Jax's room? So we need to find the square root of 144, which is 12. Then we need the square root of 196, which is 14. Then we're going to subtract 14 minus 12, which equals 2 feet. Okay? So now you need to do the odd numbers and make sure you fill in this part up here for a grade.